Alright, so welcome back to another video. So in this video, we are going to configure the decryption policy. So currently my PCs are going inside to outside, that's all correct, but they are able to reach on the 443, but 443 is encrypted traffic, which my Palo Alto is not able to check for now. Because we are not decrypting the traffic on the Palo Alto, so the Palo Alto is just forwarding the traffic. So it is not able to see what is inside the traffic, and it is not able to scan it and detect the malware inside the port number 443. So that's why we have to decrypt the traffic, and once we decrypt the traffic, then we can see. Now, it's a there are two different ways how you can configure, but the best way will be that making the Palo Alto itself as a certificate authority and using that certificate to decrypt the traffic. Now, coming to the concept how decryption works is like the PC is trying to communicate with the internet, which is my ISP. All right, so in order for the Palo Alto to decrypt, okay, it is going to decrypt, and again when it sends, so when the packet comes to the Palo Alto, it will decrypt, and after that it will send it to the ISP, but again he has to re-sign that certificate. So to re-sign that certificate, only certificate authority has that capability to re-sign or sign the certificate. Sign or re-sign, only certificate authority or subordinate certificate authority. So these are the two different roles who has the capability to decrypt and re-sign. So whenever we are doing a decrypt, that you have to keep in mind that we need to get a certificate which is capable of re-signing that certificate. Okay. So what I will do is that I will configure my Palo Alto as a certificate authority, then I will decrypt and check the traffic and forward the traffic. And whenever we go to the outside internet, since Palo Alto is generating its self-signed certificate, so that is not trusted on the internet, so we should be able to maybe or may not be able to access the internet, because whenever we try to access the web pages, they might block our traffic. All right, next. Another way of configuring is that if you can get a certificate, subordinate certificate, subordinate certificate authority certificate. So subordinate means it's like an hierarchy. So first will be the root CA, and this root CA has the like an assistant. That assistant is known as a subordinate CA. So they can have multiple of them. So now root CA has the capability to sign and re-sign. Same goes to the subordinates also. So the hierarchy will be like, for example, this one is Microsoft, and Microsoft is saying that let's encrypt will be my subordinate CA, which will issue the certificates, sign and re-sign the certificates, and you are the customer who got the certificate. So the hierarchy will be Microsoft first, which will be the root. Next will be the let's encrypt, which is your subordinate. Then after that, that is your certificate, customer certificate. So that's the hierarchy. But if you have only the root CA, you don't have any subordinate CA, then you don't have this. So the hierarchy will not include that let's encrypt in between. So you're getting the certificate directly from the root CA. Now, this root CAs and the subordinate CAs are recognized and trusted over the internet. So whenever you try to, so whenever the Palo Alto uses this certificate, which is trusted over the internet, when it signs, resigns and send it to the internet, they will accept your traffic and you are able to open the web page. So these are the two different things. So this one will be a little bit complicated one. So that's why I'm not going with that. The best will be that we will make the Palo Alto as a certificate authority so that it has its own rights, signing and re-signing of the certificate. All right, so let's go to the management PC now. So we will first go to the policies, not policies. First, we will go to the device, and inside the certificate management, we will go to the certificates. So click on generate over here at the bottom, And now you see that local or SEEP. So we want local because we want our local Palo Alto. Certificate name will be PA-CA. Common name will be pa.sysable.com.eu. Signed by the external authority. You can just make this Palo Alto as a certificate authority simply. OCSP responder, we don't want to check online. The key and everything should be fine. Now the attributes, I will include the attributes as such as country, locality, state, organization, department, host name, and IP address. So these are the different, what do we say, attribute values you can include. So country, I will give it 2 digits one, and the locality, I will say Melbourne, state, I will say FIC, organization, I will say Sysable, which is my, and the department, I will say IT, enter, and the host name will be paloalto.sysable.com.au, and finally the IP address. Okay, so the IP address will be 150.1.7.50. So I'm giving these values so that when we are decrypting the traffic, when we check the certificate, we can verify that who is uh, decrypting the traffic and who is signing the traffic. Sorry, certificates. Okay, that should be all good. The name, I think, underscore CA, that should now, minimum length is 6, 1, 2, 3, 4, 5. So I would say Palo underscore Alto underscore CA. All right, that should be all good. Click on generate. Successfully generated, that's all good. Let's go to the policy now. And in the policy, decryption policy, click on add. And now here I will say decrypt. So I will say the source will be from inside and DMZ, both of them. Because if we go to the topology, the corporate network include the inside as well as the DMZ. But you can exclude the DMZ because that will be the servers. We don't want to check on the servers. So I will say inside. Destination will be the outside. Service can be anything. And option is like decrypt and select the SSL forward proxy. Okay, so we are doing the certificates because the 443 works on the TCP 443 that uses the certificate in order to encrypt the traffic. So we that is called SSL. So we will decrypt that SSL forward proxy. All right, so log unsuccessful handshake, log successful handshake also, both of them, and click on OK, and click on commit and commit. So now if it is not still committing because when I go to Facebook, so now you can see that cancel certificate, connection is secure, more information, view the certificate. Now you can see that the certificate common name is Facebook and which is being issued by the DigiCert, okay, for the Facebook. So now what we should be doing is that in the issuer name, we should be seeing our Palo Alto certificate because Palo Alto is signing the certificate and forwarding the traffic. Okay, so the forward decrypt trust certificate is not configured. So it is saying that you the Palo Alto certificate which we have created. Okay, so if you select that one, okay, and we should be, we need to trust the certificate. So I'm just looking the way where how we can. Okay, let me delete this one. Let me create one more, generate, because that should be certificate name Palo Alto underscore CA. Name will be pa.sysable.com.au I will select certificate authority. I think I have been selected signed by external authority, so that might be the mistake. So, right, so let me go ahead and do the same thing now. I will exclude the IP for now. Okay, organization will be Sysbal, department will be IT. Okay, that should be all good now. Click on generate. Generated successfully. Now it says CA, that's good. So now I will click on that one, and now I should have these options here. So it says that forward trust, forward untrust, and trust root CA. I will select all of those options so that the certificate is being trusted by the Palo Alto. Click on OK. And now I will go ahead and commit. So once this commit is being completed, so what should I see is that whenever I now go to the internet, it should Palo Alto should resign the traffic. So again, when you resign the traffic which is not trusted over the internet, so some of the website might accept your traffic and some of them might not accept at all. So you're not able to access some of the website, but some of the website you are able to access. It depends on how secure those web servers are. Okay, almost committed. So I'm using the same management PC because management PC is also going via the Palo Alto. Okay, that's good. So let me go ahead and check with the file. Now, you see that Facebook, it's not giving the lock. So it's giving the proper encrypted one. And now you see that it is not being signed by the Palo Alto. Let's check with the other one, that is the Wikipedia. You see that Wikipedia and view certificate. Now you see that Palo Alto is signing this one. But for the Facebook, when we try to access, it is not re-signing. It is not decrypting and re-signing. But when we go to the different website, that is the Wikipedia, it is decrypting and re-signing the certificate. Now, the reason for that one is that because Facebook is using something called as a elliptic curve. So this is a, what do we say, a latest technology of providing a certificate which is more secure than the previous ones. So in order to decrypt this traffic, then we have to configure our Palo Alto in such a way that it act as a proxy. So currently the Palo Alto is just taking the traffic, decrypting it, checking it and forwarding it. But when it is decrypting and forwarding it, it is still acting as a proxy, but it is not able to decrypt this elliptic curve certificate. For that one, again, we have to set up Palo Alto in such a way that it is also able to decrypt that particular type of certificate. Okay, for now, definitely Palo Alto is able to decrypt the certificate like SSL and RSA certificate. It can decrypt that traffic and it can check and re-sign that certificate for that. But currently it is not able to do this one because we need to set up our Palo Alto for that one, which is like a little bit advanced one. So that's why I'm not including that in this one. So now you can see that we are now decrypting the traffic. That means the Palo Alto is whenever we go to a different website, it will be, now you see that I'm not even able to open the web server also like websites because that is being signed by the Palo Alto, which is not trusted over the internet, and people, all the web servers are blocking our traffic. Okay, so if I go back to my Palo Alto and if I go to the ACC dashboard, and here if I go to SSL activity, I should see that the traffic decryption failure reasons, successful key exchange and everything, the data, some kind of data should be populated. You see that not decrypted, decrypted. Traffic data, this one is others. So this one is non-decrypted 6.26 MB, and it should also, since the decryption did not fail, so that should be fine. TLS and others. So yep. So once we configure the elliptic curve ones and those things, so some of the time it will block the traffic. It will not decrypt. That's where we can see the decryption failing traffic and all those things. But for now, at least you can see that the decrypt and non-decrypt traffic is going on. And another way to check would be to go to policy, and in the policy, if you see that there is an hit count. So it been hit and it is doing it as we configured it. So I hope this was informative for you, and thank you.